Hello viewers, welcome to Kit Coder. My name is Tulasi. Today's topic is any-based multiplication in Java. So let's get started. Okay, hello friends. Today's topic is any-based multiplication. So we are discussing about that. So let's do the regular multiplication with decimal numbers, and then we can shift to the any-based multiplication. Okay, here we took octal numbers. So let's first do the multiplication with decimal numbers. Okay, 976 2 5. Okay, 6 5s are 30, 3 is carry, 7 5s are 35, 35 plus 3 38, 3 is carry, 9 5s are 45, 45 plus 3 48, 2 6 are 12, 1 is carry, 2 7s are 14, 14 plus 1 15, 1 is carry, 9 2s are 18, 18 plus 1 19. Now what we are doing? A 0. Here we are doing plus, and here we are doing into. 8 plus 2, 10. 8 plus 1 plus 5, 9 plus 4, 13, 14, 2. So this is the answer. So what we are doing, the first step is, here the first step is, we are doing these numbers. So the first step is 976 into 5 we are doing. Okay, we got answer like this. Okay, 4880. And the second step is 976 into 2. We got some solution like x1, and we got some answer like x2. And what is the third step we are doing? X1 plus x2 means the first digit should be multiplied, the first number should be multiplied with each digit of second number. Okay, 976 into 5, 976 into 2. And again we are adding these two numbers, so that is nothing but the multiplication. But what we are doing in decimal numbers are, so this in decimal numbers 0 to 9 numbers are allowed. It's okay. But what about the uh, octal numbers? What about base? What about binary numbers? So what about hexadecimal numbers? So there is only some up to limit. Okay, and we have to convert them. I already explained how to convert a decimal to any base number. Okay, let's start quickly the multiplication of octal number. Okay, friends, let's start multiplying these octal numbers. So let's see what is the strategy here. First of all, 7 into 2. What is 7 into 2? 14. So what this 14 is in decimal form. So we have to convert it into octal form. So how can you do this? Simply 14 divided by 8 and one time cancel, and the remainder is something but 14, no? 6. Okay, and again take 8, 0, and the remainder is 1. My octal representation of this 14 is, 14 base 10 can be represented as 16 to the base 8. Means 16 is the octal number. So let's take 6 here and 1 here. Okay. And again, what we are doing now, let's say this. Okay. And let's start. So 7 into 3. 7 into 3 is 21. 21 plus 2, 22. So we got 22 of base 10, but we want base 8. So what we will do, 22 by 8. 2 times cancel, 16, 6 is the remainder, and 8, 0 times 2. So 26 is the uh, octal representation of 22 of base 10. 26, no, 6 here, 2 here. Okay, 7 4s are 28. 28 plus 2, 30. So 30 is of base 10. So we have to convert into base 8 number. So what we will do, 30 to the base 8, 3s are 24, 6 is the remainder, and 8, 0, 3. So 36. Here we will come 36. 36 is the octal representation. So 36. So like this, you will multiply. Okay, again, we can continue. Okay, let's start with 2. 2 into 2, 4. So what 4 is of base 10. So what is the octal representation? 4, 8, 0 times 4. Okay, it's nothing but the 4 is as it is. In decimal format. Okay, in decimal format, it is of 8. Okay, in decimal number and in octal number also, it is 4 only. Okay, let's consider 4 now. And 2 3s are 6. So in decimal number and in octal number also, it is 6. 4 2s are 8. But it is not a 8 of base 10. We have to convert into base 8. So what we will do? 8, 8, sorry, 1 time. It's 1 time and it's 0 times. And again 8, it's 0 times 1 time. So the octal representation is 1, 0. So we can take it as 1, 0. Okay, let's add these two octal numbers. And I also explain how to add two octal numbers. Any base addition I already explained. Again, I will explain for you. Okay, let's start adding these two octal numbers. So 6 plus 0, 6. It is not exceeded 7. So in octal numbers, we have numbers from only 0 to 7. But it is not exceeded 7, no? So as it is. What is 6 plus 4? 10. It exceeded 7. So what we have to do? 10 modulo division 8 and 10 by 8. What is 10 modulo division 8? 2. 2. And what is 10 by 8? 1. Okay, 10 modulo division 8, 2 here, and 10 by 8 here we are taking like carry. And 6 plus 1, 7. 7 plus 6, 13. So what we have to do? 13 by 8. 13 by 8 we will get 13, no? 5. Okay, and 13 by 8 we will get 1. So 13 modulo division 8 here 5, and 13 by 8 here 1. And again 3 plus 1, 4. 4 is not exceeded 7. So as it is we can represent 4 and 1 as it is. So that's it. That's it about this octal multiplication. Simple. But I have to tell one shortcut to this, because here when I'm multiplying, for suppose 6 2s are 14, what I'm doing is 14. Again, I'm converting into octal number. So what I'm doing is multiplying it with 8. Okay. And here I will get 1. Here I will get 6. And again doing up to it occurs 0 and 1. So 1 6 is the octal representation of the number 14. But easily we can say 14 by 8 and 14 modulo division 8. 14 modulo division is obviously 6. 14 by 8 is 1. Means we got 1 6 here. So 1 as carry, 6 as this number. Okay, we can simply write this. So no need of again writing how to convert a decimal to binary, sorry, decimal to any base number. We have written some code, no? So no need of writing that all the code. We can simply write 14 modulo division 8 6 here and 14 by 8 1 here. Here 8 can be any base. 8 can be any base. 2 3 4 5 6 7 8 9. So it can be any base, but 14 by 14 modulo division 8 is here, 14 by 8 is carry. And in addition also same like that. 13 by 8 5 is here, 13 modulo division 8 5 is here, 13 by 8 1 is here. So this is about the any base multiplication. So what are the few steps that I have told before? The first step is multiply multiply the multiply the first number with every digit of second number. Okay, that is the first step. So what is the third number? Add that result. Add that all results. So that's it. We know how to multiply. We know how to add that all the result. So that's it about this int-based multiplication. So let's start coding in Java. Okay. Okay, let's start coding, friends. So there is my get product method. In that method, I have base and I have two numbers. Okay, we have to multiply the two numbers. Okay. what I'm doing is, let's take int result is equal to 0, okay, and int p is equal to 0, and while my n2 is greater than 0, what I'm doing is each digit of n2 I'm multiplying it with n1. So as I said already before, let's take int d2 is equal to n2 modulo division 10. Okay, I will get some digit now, and again I'm decrementing this digit by 10. Okay, except the unit digit number, you will get the remaining digit. Let's take int the, let's take separate product, like digit wise product, like digit product. Let's take digit product, and in that I'm passing some function like get product with a single digit. Okay, I'm taking like this, and I'm passing b base n1 and my digit d2. Okay, so I'm multiplying to this function now. I'm writing that function separately here, so see that. So public static, so public static I'm returning to get get product with a single digit. I'm passing int base int n1 and int b2 d2. Okay, let's complete this function. So what this function mean is, so let's take here again result is equal to 0, and let's take a carry as 0. Let's take p is equal to 0. Okay, while my n1 is greater than 0 or my carry is greater than 0, so anything can be possible. So don't worry, I will also explain this by tracing out the code, don't worry. Okay, let's take int d1 is equal to n1 modular division 10. Okay, and n1 is equal to n1 by 10. Okay, let's take d is equal to d1. Okay, d1 into d2, and I'm adding, is there any carry or not, I don't. What is my carry now? I already explained, carry is equal to d by 8 or modular division 8 by 8, so by b. Okay, what will be my digit now? D is equal to t modular division b. Okay, and what will be my result? Result plus is equal to d into math dot power of 10 comma p, and again now I'm incrementing my p. So let's take p plus is equal to 1. Okay, so that's it about this get product with a single digit. So let's return that, return result. Okay, here we will get a result now. So here we will get digit product. But what we have to do, the what is the next step you are thinking? Okay, let's pass it to the, so after getting the every digit product, so what is the next step? We have to get the addition of all the numbers. So what I'm doing is I'm simply like addition result is equal to, I wrote some function get some function. In get some function I'm passing base. Okay, and this let's take, let's take the result. The result is equal to b comma a. Again I'm passing that result and my digit product. See my digit product. So I'm passing the digit product. Okay, digit product. Okay, I'm passing in get some function I'm passing b and result, and again this get some result will store in result, and again I'm passing that digit product into math dot power of 10 comma 2. So why I wrote like this, I will explain. Okay, I will trace this code, so don't worry about that all. So let's return a result. Okay, now we have to write the get sum method. So I already explained about the any base addition. So again, let's write the static int get sum. In get sum method, we have sorry, int base, okay, int number and int n2. Okay, we have number n1 and number n2. There is no get sum method here. Number n1 and number n2. What I'm doing here is, let's take int result is equal to 0. Okay, and like int carry equal to 0 and int equal to 0. Okay, and while n1 is greater than 0 or or and n2 is greater than 0 or my carry is greater than 0, what I'm doing is int d1 is equal to n1 modulo division 10 and int d2 is equal to n2 modulo division 10. Okay, and my n1 will be n1 by 10 and my n2 will be n2 by 10. Okay, my int d will be d1 plus d2 plus carry. Okay, my c will be c. What is that? D by b. What is c is nothing but carry. Okay, and my d will be d modulo division b. Okay, my result plus is equal to d into math dot power of 10 comma b. I'm incrementing b by 1. Okay, returning something, return result. Okay, so that's it about what I wrote. First of all, I will explain get product method. In get product, I initiated a result with 0, p with 0, while nt is greater than 0. Each digit of n2, I'm producing it with n1. Okay, in get product with a single digit method, what I'm doing, I'm storing result carry p while n1 is greater than 0 and carry is greater than 0, each digit of n1. Okay, I am multiplying it with and I'm adding carry, and carry will be d by b and d will be d modulo division b and multiplying with it. So this is very similar to the addition. So if you see these two, get sum and get product with a single digit function, instead of here into, I'm just doing plus. So that's the little difference. Okay, so that's it about this code. So first of all, let's run this code, and again I will explain this by tracing out the code. Is it passed or okay, friends? Let's run this code. Um, okay, it is accepted. So let's submit. Okay, correct now. So let's analyze this code. Okay, 1 minute. So one thing I want to tell you people is I already explained any base addition. Okay, so I request you people to watch that video. I'm not explaining this get some method, and the starting of this video I already explained how okay the single digit is taken, okay, how the carry is going on. So if you saw this get some I mean any base addition video, you can also get a full idea of this get product with a single digit. Okay, and it's very easy to understand. Okay, let's trace out the code. I am giving you this as assignment. So first try to watch the any base addition video, then you can also understand this get product with a single digit. This code is very similar to the any base addition code, I mean get some code, and this is also you can easily understand. Okay, I request you people to watch that video. Okay, thank you for watching. Thank you friends, thank you for watching. So the next coming up video is decimal number to Roman conversion in Java. So it's very important for interview purposes or for any coding competitive exams. So like this, okay? So let's wait for this. Thank you.